back. This is part 5 of my Microsoft Access tutorial. Microsoft Access, the affordable database management solution which we've been working on. Previously, we joined two tables into one table for purpose of querying. We also joined two tables and then joined that query to another table. That's a way to nest queries, which can give you more flexibility. Um, we talked about the various different kinds of join and what they imply. Remember, different joins have include different material from a table. Sometimes a join will exclude records which are incomplete or rows which have incomplete information. Sometimes a join will include that information. It depends on which type of query you want. And today we're going to be looking at relationship diagrams for an entire database or schema and different types of relationships between tables or between tables and queries. So if you want to look at the entire database, our database is very small, so it's not a big deal. In a graphic format, you go to the Database Tools ribbon and select Relationships to see the relationship diagram. We've seen this in passing before, and we see that Orders is kind of the center table. It has the most columns. All the other tables kind of feed into it. Since orders and generating orders is the principal activity of the business, we expect it to be the largest. And all the other items kind of orbiting around it contribute to it. But since we're focused on orders, employees will only come in when it's relevant. Products will only come in when they're relevant. Purchasers will only come in when they're relevant. And way off to the side, in a second degree relationship, is vendors. We're going to consult vendors even less. We don't need to know the vendor of the property vendor of the item when we're when we're entering an order, unless we're doing some kind of wholesaling thing. So the convenience of this is you only need to update the tables relevant to your activity at any given time, and all the other tables sit dormant. You don't have the risk of transcription error or read-write error if those tables are not opened every time you consult the orders table. Dividing things off like this also makes database run more efficiently because you're simply not opening as much information at once. So if a table, all the tables we've seen have been joined, of course. They share columns. Orders shares a column employee with the employees table. It shares product column with products table. Purchaser column with the orders table. And of course, products shares vendors column with the vendor table. Now, of course, the columns in each iteration, each of those two columns in the match may be slightly different. They may contain slightly different stuff. There may be different instances there may be vendors that exist in the vendor table that don't offer any products. So they may not show up in the, they'll show up in the vendor column, but since they don't have products, they may not show up in the vendor column of the products table. If they're not, but we want their record, so they'll stay in the vendors table anyway. There may be employees who never sell anything, so their name may not show up in the employees column of the orders table, but we still need to keep track of them. And also you can have tables with no joins. You can have tables that don't share any column with any other tables. Um, Kind of pointless, but if you're building a database, sometimes you have yet to make the relationships uh, explicit. Or if you have some old tables that are no longer relevant, you may have eliminated their connections. That doesn't mean that it can't sit in the database. It's just not going to show up in the relationship diagram. So let's look at a relationship diagram. Go to Access, Database Tools, Relationships, and there's our relationship diagram, as I've said. Now there is a table called Charity List, which I made up. Charity List has donors who could be either employees or customers, because it's a company charity, how much they contributed and whether they got a thank you note. And if you look at the donors, Tim Curry and Sean Connery are purchasers. But if you look at the charity list, donors Julie Boole and Jackie Blue are employees. But so they don't share a common column with any, they don't share a single common column with any table. It's going to be mixed up. You could link donor table to employees, and then you run the risk of purchasers showing up in a query that involves employees. So basically what I want to say is charity list will not show up in the relationships table. If you look closely, you'll see it's not there. The same old table, same old relationship diagram as ever. Charity list does show up in the side in the list of tables, though. And maybe we'll eventually link it. We would link charity list by making a column like names. And then everyone associated with a company might be on the names table. We could use that to assign parking passes or Christmas cards or tax information. Every name associated with a company would be in that table, and that could be linked to both employees and purchasers. But I'm getting a little far afield. My main point being, unless you have a link, unless you have a join condition, a table may exist in the database that does not show up in the relationships table. So let's look at a relationships table, and let's specify all the rows with unique values. The primary key of each row is the ID number, which is kind of the equivalent of a line number. It doesn't have no information relevant to the semantic information of the table, just a unique number which distinguishes that row from every other row. But in the employees table, employee number and employee name, also known as employee, those are values which do not repeat. Each employee only occurs once. And of course, employee number only occurs once. We could technically have employees with two employees with the same name, in which case employee number would be different. And of course, the line number they were on would be different. But in this instance, we don't have any repeating employees. But yes, if you're designing a professional database, yeah, you're going to take into account multiple people with the same name. Orders, product and order number and ID, or order number and ID are the unique items. order number is the only item in this table, which is where the column is going to have unique values, because product is going to be repeated every time the product is ordered. Actual charge, shipping charge, shipper, purchaser, employee, they're all going to recur. Let's look at an example just so it's clear. Purchaser, or not orders, sorry. Orders, you see the product repeats. There's only 3 products in the inventory. Price doesn't repeat, but it could. Shipper repeats, purchaser repeats. In some instances, you see purchaser repeats, so it's not a good way to no, it's not a way to distinguish unique rows. But order number, of course, although it's not the primary key, it is the unique value that we use to join to other tables. So when you're looking at a database, you want to know which columns have unique values, whether it's the primary key or not, and those columns are going to be columns that you're going to join on. There's another way of looking at this, and that's a one-to-many relationship. A one-to-many relationship is how a join works, usually. Looking at it simply outside the context of databases, you have a cat, and the cat could be any number of different breeds, assuming the breeds don't interbreed. A cat could be a tabby or a tortoiseshell or a manx. Or think of maybe better analogy would be a tiger, a cougar, a panther. Technically, they can interbreed, perhaps, but think of these as types of an animal that are completely separate from each other in separate categories. That's a one-to-many relationship. A one-to-many relationship is what you'll find in a database where in one table you have the unique value of purchaser. The purchaser table, the purchaser is unique, but the purchaser may show up several times when you join it with the purchaser table in orders. Let's look at this again. Purchaser table in orders. Purchaser keeps showing up over and over again, same one. Keeps coming back. There's only, purchaser is repeated repeatedly in the orders table. But in the purchaser table, there's only one for each purchaser. So it's a one-to-many relationship between purchaser in the purchaser table and purchaser in the order table. You need to keep track of these one-to-many relationships because it's how you organize the data and limit the data you need to present. So here's a flow of one-to-many relationships. Maybe this will make it easier to think of. The arrows point from the unique value to the multiple value that's going to appear. So each employee only appears once in an employees table, but the employees are going to appear multiple in the orders table. Use the laser pointer. Orders table, employee appears multiple times. Employees table, employee appears once. Orders table, sorry. Orders table, employee will appear multiple times because each employee makes, dozens of orders. Products table, the product will appear one time, but in the orders table, it will appear multiple times. I've repeated this ad nauseum. I'm sorry, but the one-to-many relationships flow, as you see from the arrows, flows towards the center orders table, the table which documents most of the activity, and the table which has the most columns. So think of these arrows when you see this relationship diagram, one-to-many relationships. So, of course, the right-hand value in a one-to-many relationship will be a separate and distinct example of the value. Each, on the right-hand side, you'll have a separate and distinct example of the value in the left-hand column. So, Tammy Hall, one employee has 4 orders. Each order has a different number. Joe has different roles as a person, and each one of those roles is distinct from the others. And you organize data in queries by lining up the unique values, and then lining up the many side of the relationship dependent on the unique value. So let's look at a one-to-one in Access. So let's go to the employee plus order query. We've joined the employees, pulled it up over here, employee plus order. I'll close it so we bring it up again. Employee plus orders. The table, when we look at it in datasheet view, has all the employees on one thing, and we've joined it to the order table, and the employees are the orders the employees made line up very nicely. Let's look at it in design view. Employee exists uniquely. Each employee only occurs once in the employee field, and it's joined to the employee field in the order table where it will appear multiple times. And let's look at it at datasheet view again. It's the one-to-one relationship is not clear if the employees are out of order. So let's put it in order by order number just to confuse everyone. Now we're in order by order number, and the one-to-many relationship is not clear. There's no one-to-many relationship here. Put it in order by employee. Now the employees are alphabetically arranged. You can see Jackie Blue, one value with 2 orders. Jay Bird, one value with 1 order. Jim Dandy, one value with 0 orders. Tammy Hall has 4 orders. And of course, we can't put her orders in order necessarily because we've put the table in order by name of the employee. So let's look at something. We have a feature here called Create Report, which will make this look a lot neater. When you're looking at database tables, unlike in spreadsheets, you can't really remove the duplicate names. It doesn't look neat. It looks confusing. If you know what you're looking for, it's pretty clear there's several one-to-many relationships here. But, there's 2 one-to-many relationships in this table, but by definition, because of the nature of databases, there's, you might want to consider the one-to-one relationships, one-to-many relationships too, because every relationship is the same, but that's getting a little semantic. But we cannot make the different iterations of the extra iterations of Tammy's name disappear or Jackie's name. So it looks a little uneven. So there's a report feature. Create report. It's going to give me a printer error. which will hold things up. It's waiting for a printer correction, and I don't have a printer hooked up. It'll take a second. Report is usually an executive summary which is produced on paper or in a chart for or in the web for public consumption, and it's neater and can be styled um, because databases do not necessarily style because you're meant to have behind the scenes um, access to the material. This So here is your report, which is the same table in graphic format, but under employee in the report field, you can go group on employee, and that eliminates all the duplicate employees. So Jackie Blue is only listed once with her 2 orders. Tammy Hall with her 4 orders, listed only once. So the one-to-many relationship becomes much clearer. You can clearly see who has the most orders, who has the fewest, who are the intermediate ones. And it becomes very clear. You can print this out or prepare this as a web document. Since I didn't have a printer hooked up, it gave me a bunch of errors we had to cancel. But the one-to-many is very clear here. And the one-to-ones are very clear. Jaybird has a one-to-one relationship. Jim Data has a 1-to-0 relationship. But if you're envisioning databases as flows of a series of one-to-many relationships, this is an excellent way of envisioning it. That you can't really do in the table view because the customer doesn't see the table view. This is for the use of the person doing the querying. The executive doing the decision making will want to see the report instead of the raw data that we see. And you're basically just suppressing duplicates. And it looks much neater. So let's quickly view and edit relationships. We viewed relationships in the view relationships feature for individual queries and for entire tables. Go to the database tools ribbon and you hit the relationships button. We've done this already. And we get a view of them. But there's also the edit relationships button, which will bring up a series of dialog boxes, which are more sophisticated than the edit relationships dialog box we saw when we were just editing relationships in individual queries. Join properties is a separate dialog box, which will bring up, and you can create new relationships. This is a little heavy duty for what we're doing right now, but I want you to see how it looks. And let's go and see again. Database tools, bring up relationships. There's your relationships diagram. Highlight the relationship and hit the edit relationships option. You can change the join type. You can change it to a left-hand join or a right-hand join in case you want to include columns that have incomplete information, or you can select the inner join, the standard join I've been using. It's not necessarily very wise to alter relationships at this time. Later on, we'll have a demonstration of how to include uh, incomplete columns so you get a more complete view of all the data, even if there are empty cells, using right and left join. But right now, I just want you to see how this looks. Again, you select the tables you want to join, and then you select the columns inside the tables that you want to join on each other. And you can delete a relationship if you want to. Maybe you want to rearrange the table, put in an intermediate table, which will create different relationships. But I just wanted you to see how the edit relationships feature works in this dimension. Edit relationships from the edit relationship button, or from clicking on the individual relationship line. So thank you for watching. Today we looked at relationships in terms of diagrams and the flow of the one-to-many query. We looked at the definition of one-to-many relationships, one-to-one relationships, and many-to-many relationships. We want to eliminate many-to-manys because they're too chaotic. Remember, we went and changed a many-to-many relationship either by organizing a field, organizing a column so that everything, the one-to-many relationships become more apparent, or by interposing a new column, like order number, which will impose better organization on a table. And I think the thing you most want to come away from here is a sense of which columns are going to have unique values in a database, and how the one-to-many relationships are going to flow from the column with the unique value to the column with the repeated value. The flat end of the arrow having the unique value, pointed end of the arrow having the repeated value, and how they all kind of flow into the center table, which is the largest and widest table with the most columns, which reflects the business activity core to the enterprise, namely orders. And envision the flow to see precisely how the database functions and how everything is arranged. So thank you for watching. Next time we will be doing more on joins, different species of joins, and